Photoelectric effect, photons, threshold frequency. In this topic, we will discuss the following subtopics: photoelectric effect, photons, threshold frequency, work function, Planck's constant, and electron volt. Factors affecting photoelectric emission, photons, Einstein's equation, applications of photoelectric effect including photoemissive devices, photoconductive devices, and photovoltaic cells. Introduction. When light with a frequency that has sufficient energy is radiated on a metal surface, electrons are emitted. This phenomenon has wide applications in life, such as construction of solar panels for green energy, automatic counters, streetlights controls, and alarms. Factors affecting photoelectric emission. The following factors affect the emission of photoelectrons from a metal surface: the intensity of the incident radiation, the type of the metal surface, and the frequency of the incident radiation. Play the animation below and observe how these factors affect emission of photoelectrons. Observations. When the intensity of the light is increased, more electrons are ejected from the metal surface. Explanation. Increasing the intensity of light implies that more energy reaches the metal surface. This energy is used in injecting more electrons, which are attracted to the anode. By using different metal surfaces, it is observed that different intensities of the emitted electrons are achieved. The least emission of electrons is achieved with nickel, while lead has the highest emission with the same light being shown on the metal surfaces. Explanation. The energy required to remove electrons from a metal differs from one metal to another. With different frequencies of the incident light, the number of electrons emitted is seen to vary. Higher frequencies emit electrons with higher energies. Photons. Electromagnetic waves such as light travel as packets of energy called photons. Packets for a particular wave carry an equal amount of energy. The illustrations below show the photons for red and blue light. Click on the play button of the animation below to observe photons packed with different amounts of energy in motion. Threshold frequency. This is the minimum frequency of light below which no electrons are ejected from a metal surface no matter how intense the light is. This is represented by F0. Play the animation below to observe the ability of photons to eject photoelectrons depending on the amounts of energy they possess. Work function. This is defined as the least energy required to eject an electron from a metal surface. It can be calculated from the equation E is equal to hf0 and is denoted by W0. The work function varies from one metal to another. The electron volt. This is a unit of energy equivalent to the energy gained by an electron accelerated through a potential difference of 1 volt. Its value is 1.6 multiplied by 10 to the power of negative 19 joules. It is more convenient to use this unit when dealing with small amounts of energy. 1 electron volt is equal to 1.6 multiplied by 10 to the power of negative 19 joules. Einstein's equation. This equation gives the kinetic energy of the electrons emitted during photoelectric effect. The energy of the incident photon is transferred to the work done in removing the electron from the metal surface, and the rest is transferred to the kinetic energy of the electron. This implies that energy of the incident photon is equal to work done in removing the electron plus kinetic energy of the emitted electron. HF is equal to work function W naught plus KE. HF is equal to HF naught plus KE. EV is equal to work function plus a half mv squared. Photoemissive devices. These are devices which have a photoemissive cell. In a photoemissive cell, the incident light on the cathode ejects electrons which move to the anode, constituting an electric current. Examples of such devices include signals from a photocell receiving light from the soundtrack recorded over a movie film, which is amplified and used to drive loudspeakers. Photocells can be used in counting items on a conveyor belt as they pass. When the item passes between the light source and the cell, they block the light, reducing the cell output. This increases after the item has passed. An external source is used to count the light pulses electronically. This can also be modified to work as an alarm. Photoconductive devices. These are devices with a light-dependent resistor, LDR, which changes its resistance depending on the intensity of light falling on it. The change in resistance alters the current on the device, which is operated depending on the light intensity. Examples of such devices include light-operated security lamps and gates. Click on the play button to make your observations. Photovoltaic cells. These are cells that generate an EMF when light falls on them. They consist of two different materials placed together to form a junction. When light falls on the junction, electrons are freed from one end of the material to the other, creating a potential difference. Solar cells are constructed from layers of semiconductor materials that generate sufficient current to charge batteries. Examples of other devices operating with photovoltaic cells include traffic lights, watches, calculators, cameras, light sensors, among others. Photovoltaic cells. These are cells that generate an EMF when light falls on them. They consist of two different materials placed together to form a junction. When light falls on the junction, electrons are freed from one end of the material to the other, creating a potential difference. Solar cells are constructed from layers of semiconductor materials that generate sufficient current to charge batteries. Examples of other devices operating with photovoltaic cells include traffic lights, watches, calculators, cameras, light sensors, among others.